Unit 7, Day 5, Angles of Elevation and Depression. An angle of elevation is an angle measured from the horizontal plane upward from an observer's eye to a given point above the plane. What that means is we're going to take this observer, and the very first thing is we need to draw out his horizontal line of view. So this is directly from his eyes. Angle of elevation, this means that he's going to tilt his head upwards to look at an object that is taller than him. So as he tilts his eyes upwards, we end up creating this angle that is above the horizontal plane. For an angle of depression, it's an angle measured from the horizontal plane downward from an observer's eye to a given point below the plane. So again, we start out with the observer's horizontal viewpoint, and then he's going to depress, which means his eyes are going to go downward to look at something on the ground or something below him. The angle that we've created is one like this. So it's important to know what the difference between elevation and depression are so that we can work on these problems. Here, let's just work on trying to identify what is an angle of depression and what's an angle of elevation. So for angle 1, from this person, we're going to start out horizontal. To get the other side of the angle, we need to go downward, so this is an angle of depression. Angle 2, you start out horizontal. To find the other side of the angle, we're going upwards, so this is an angle of elevation. Angle 3, again, that's the horizontal. To find the other side, we have to go downwards, so this is an angle of depression. And then angle 4, this is the horizontal. We're going to move upwards to get the other side, so this is an angle of elevation. Now I want you to pause and then look at this diagram and try to determine whether angles 5, 6, 7, and 8 are angles of depression or elevation. And then you can press play and check your answers with me. So go ahead and check your answers. You should have that angle 5 is an angle of depression, angle 6 is elevation, angle 7 is depression, and angle 8 is elevation. So in terms of the math, we're not actually going to do anything new this time. We're going to take our understanding of angles of elevation and angles of depression and work on your favorite, word problems. So in order to work on this word problem, first we have to draw a picture. So after you read through this, a person is standing 40 feet from a flagpole. So first, let's just draw that. We have a person and we have a flagpole. And we know that the distance between them, they're standing 40 feet apart. Okay. Now, it says the person can see the top of the pole at a 35-degree angle of elevation. So if they can see the top of the pole, that means first, from their eyes, they're going to look straight out. Now it says it's a 35-degree angle of elevation. So we want our man to look upwards so that he can see the top of the pole. So from his eyes, now he can see the top of the pole. And now we just want to focus on this triangle that we've created right here. Now your picture might be a little slanted, that's okay. But the important thing to know is that we did create a right triangle. Here's our right angle, okay? And now we need to label the information that we have from the rest of the problem. It says the person's eye level is 4 feet from the ground. That means his eyes are 4 feet from the ground. So this is 4 feet. And we can also label this side, since this goes straight across. This is 4 feet. Now, it asks us to find the height of the flagpole to the nearest foot. So we want to know the entire height of this flagpole. We already know that this part is 4, but we need to know the rest of this. So that's why we're going to focus in on this triangle that we have. We know that since they're 40 feet apart, even from his eye level to the pole, this is also going to be 40 feet. This is 4, but we need to find this one. Now, we're just going to put another variable here. I'm going to put y. Oh, and I forgot to label this earlier, but this one's 35-degree angle. So let's go ahead and use SOHCAHTOA to find the value of y. So from this angle, y is going to be the opposite side. And then this is the hypotenuse, so 40 is the adjacent. Using the opposite and the adjacent, we are now going to use tangent of the angle is equal to the opposite over the adjacent. Now, just like we've been doing, you're going to solve this equation by multiplying by 40 on both sides, and then you're going to put this in your calculator to get y equal to 28. Now, that's not our final answer. That's only part of it. Y is equal to 28, but we need to know the entire length of the height of the pole. So that's what we called x, and that's equal to y plus 4. This part y plus the 4. So x is equal to 28 plus 4, since that's what we found for y. So our final answer, x is equal to 32 feet. So the flagpole is 32 feet tall. Let's try this one. An eagle perched 40 feet up in a tree looks down. Let's pause there, and first we'll draw a tree, and then yes, this is my eagle. And so it says it looks down at a 52-degree angle of depression and spots a vole. So the eagle sees a vole. Now, it's really not important what a vole is. You can just write the word vole if you don't know what it is. Okay, so we're just going to go with that. Now, it sees it at an angle of depression of 52 degrees. Now, you need to really be careful about angles of depression. These are the trickier ones. So you have to remember our initial rule. It starts looking straight out, and then from there, the angle of depression is going to go downwards, so that now the eagle is going to see the vole at that angle. Okay, so this is the angle of depression that we need to draw. Now, if we keep reading the problem, well, I guess first we can label what we know. It says the angle of depression is 52 degrees, and the eagle is 40 feet up in the air. So this is 40 feet. Alright. When we keep reading, it asks, how far is the vole from the eagle to the nearest tenth of a foot? So we actually want to know how far the eagle is from the vole. That's this distance. Now, in order to help us, we don't really need this for part of our calculation, but for our diagram, if we draw that straight line, that's going to help us. Okay, because this height right here is going to be the same distance that the eagle is from the ground. So this is our 40. And so when we're looking at this again, we have our right triangle, so we want to focus here. This is our angle. This is the opposite side. And then this is the hypotenuse. So using the opposite and hypotenuse, we're going to set up our equation. Sine of the angle is equal to the opposite side over the hypotenuse. So again, just like we did before, we're going to solve by multiplying by x on both sides. Then we're going to divide both sides by sine of 52. And then we'll cancel out. We should get x is equal to 40 over sine of 52. And then when you put that in the calculator, x is equal to 50.8 feet. That means that that eagle is 50.8 feet away from the vole. Now, looking at this example, I want you to just take a minute, pause, read through the problem, and draw your picture first. Okay, so we'll check back and see if your picture matches mine. Okay, so hopefully your picture matches something like mine. You have this hot air balloon with the woman in it, and then she sees a sheep that's on the ground. Her angle of depression, so straight out, depress, and then that angle down is 27 degrees. Then it says that she is 125 feet from the sheep, and then we want to know how high the balloon is off the ground. So this is the diagram that you should have. If this isn't what you have, go ahead and pause, erase it, and you want to make some minor changes. Okay. So now let's go ahead and solve the problem. We want to label our sides first. X is the opposite side from the angle. This is the hypotenuse. So using opposite and hypotenuse, we want to use the sine function. So we have sine of the angle is equal to the opposite over the hypotenuse. And then we'll multiply by 125 on both sides. And then when you put this into the calculator, you should get 56.7. And then of course this should be feet. So the hot air balloon is 56.7 feet off of the ground. Here's another problem, and I want you to again pause, draw the picture, and then when you're ready, check back with me to see if your picture matches, okay? Okay, so hopefully your picture matches something like mine. You have the person, and then you have the tree. They're 55 feet apart, and the person's eyes are 4.5 feet above the ground, which matches this measurement. And then this is also the same as the 55. So for the angle of elevation, you need to start out the horizontal, it needs to go upwards, and then he can see the top of the tree. That angle measure is 61 degrees. So we need to find the entire length, or the height of the tree. So we need to find that x, but in order to do that first, we need to find this measurement of y. So let's do that. From the angle, the y is the opposite side, and then this is the adjacent. So using opposite and adjacent, we're going to use our tangent function of 61 degrees is equal to the opposite over the adjacent. Now we're going to multiply both sides by 55 to isolate the variable. Then you get y is equal to 99.2. Now, that's just this measurement. This is a very tall tree. So our very last calculation, we need to find the entire height of the tree, which that x is going to be equal to the y, the top part, plus this part. So y plus 4.5. We found y to be 99.2 plus 4.5. So when you add those together, you're going to get x is equal to 103.7 feet. So the tall is 103.7 feet. That is very tall. So this is where we're going to stop for this lesson. So remember, the math portion is not new. We are specifically using this lesson and this next class period to work through taking word problems and then drawing the appropriate picture from it. And remember, like I told you in class, we really need to get a handle on word problems. You cannot just skip all of the word problems for the rest of your life, okay? Alright, so work through this, and then we'll work on more of these in class.